Welcome to the Homework Help for Section 3-5. We're going to take a look at a couple examples here from your homework off of page 211. And if you start on number 12 here, we have a function f of x equals 3 cotangent to the fourth x. And what we have to do here is we have to look at what's the inner function, what's the outer function when we're dealing with the chain rule here. Well, first off, the 3 is just going to hang out. That's not going to do anything but sit out as a coefficient. So we're finding f prime, and we look at what's our inner function. Well, it may be easier for you to look at this as cotangent of x raised to the power of 4. Well, our inner function is cotangent of x, and our outer function is raising to the power of 4. So let's deal with the outer function first. Since we're raising an exponent, that exponent becomes a coefficient of 4, and then we just write what we're raising to the power, but we decrease that power by 1, so it's cotangent cubed of x. Now, what we have to remember is now we have to take the derivative of that inner function, which is cotangent x, and the derivative of cotangent x is negative cosecant squared x. And then we can look to possibly simplify this. Well, if we simplify this, the 3 and the 4, we get 12, and so f prime has a coefficient of 12. But we're going to bring that negative out and say the negative's out front, so that takes care of the negative from the negative cosecant squared x. And if we think about cotangent is simply cosine over sine, and cosecant is 1 over sine. So we can either leave it as cotangent to the third x times cosecant squared x, or if you really want to change the way it looks, it would just be a negative 12 cosine cubed x all over sine to the fifth x. Now, this isn't really any nicer than this form, but if you want things in terms of sine and cosine, that's what it is. So either way here, this is f prime for number 12. So let's take a look at another one. Let's try number 16. And in number 16, we have the function f of x is equal to tangent to the fourth, once again, but now we're taking tangent to the fourth of x cubed. Okay, so we have to think about what functions do we have here. We actually have 3 functions going on here because we have x cubed, so x is being cubed, and then we're taking the tangent of that function, and then we're taking that function and raising it to the 4th power. So we've got a lot going on here. So when we want to find f prime of x, we've got to deal with the outer function first. It's kind of like an onion. You peel it away layer by layer and taking care of the derivatives of the subsequent layers inside. Okay, so dealing with this outer layer, we take the derivative. That means a 4 is going to pop down as a coefficient, and we get tangent cubed of x cubed. Okay, and so all we did there is we decreased the power by 1, bringing the 4 down as a coefficient. Well, then we have to take the derivative of tangent of x cubed. Well, what is that layer there? Well, we've got a function inside of a function, so let's take the derivative of the tangent part first, which gives us secant squared of x cubed. And then we need to look at, well, let's take the derivative of that inner function of x cubed. Well, that gives us a 3x squared. Now, we want to try to clean this up a little bit here. So we look at what coefficients do we have. We have a 4 and a 3, and that will give us a 12. And then we can bring this x squared out front. And we look at our trig functions. We've got a tangent cubed of x cubed and a secant squared of x cubed. And really, we can just put those together as tangent cubed of x cubed times secant squared of x cubed. And if you want to turn this in terms of sine and cosine, you can, or you can simply leave it as such. And I'm okay with you leaving it just like this. You don't need to turn it into terms of sine and cosine. This is perfectly fine. Now let's take a look at one that's a little more difficult here. Let's take a look at number 25. Now in number 25 we have the function f of x is equal to x cubed sine squared of 5x. and we want to take the derivative of this function. And the first thing you should notice is that we have a product of two functions here. And so that means we're going to have to use the product rule. And in that product rule, we are going to have the chain rule to deal with this sine squared of 5x. So let's take a look here. Now, using the product rule, we want to take the first function and multiply by the derivative of the second. So the derivative of the second, we look at as sine of 5x being squared. So looking at that as the squaring is the outer function, we get a coefficient of 2, and then we're left with sine of 5x raised to the first power. Well, then we have to look at, well, what is sine of 5x, the derivative of sine of 5x? So that gives us cosine of 5x, because the derivative of sine is cosine. But then we have to look at the innermost function of 5x. What's the derivative of 5x? Well, that's simply 5. And we'll clean that up in a second. Now let's look at the second half of our product rule here. We want to take the second function of sine squared 5x, and we want to multiply by the derivative of the first, which is 3x squared. Okay, so let's clean this up a little bit here, and we see that the 2 times the 5 gives us a 10x cubed, and then we get a sine of 5x times the cosine of 5x plus 3x squared of sine squared of 5x. Now, we could clean that up using maybe some trig identities, but we're just going to go ahead and leave it like this and say that this is our f prime function. Now, the other parts of your homework are simply using the same rules here, the product rule, the quotient rule, and the chain rule. And don't forget to, when using the chain rule, you may have multiple layers, and continue to attack one layer at a time. Take the derivative of the outer layer, then the next layer, and so on.